Okay, in this lecture, I'm going to go over how to do the Excel workbook for Unit 1 of the third topic on the first part of that. So let's go ahead and get started. I'm going to share my screen. And this right here is the Excel workbook. And what we're doing is we've got the shape of the distribution that we're looking at. So the time weighted for the gym shuttle, what is the shape? Let's see. This right here is time weighted for the gym shuttle. So I'm going to put time weighted for the gym shuttle right here. Time. I don't know why it's not in there, but time weighted for the gym shuttle. And notice it goes from 5 to 25, and every single one is about the same. So we took a sample. Let's see how large our sample is. Our sample is 51. We took a sample of 51 people, and 51 people gave this information, and you notice that it's pretty close to the same all the way across. You know, we've talked about bimodal data, trimodal data, whatever, but if you've got data that's just pretty uniform or pretty much the same all the way across, that's referred to as a uniform distribution. So we're going to come right up here and we're going to put uniform. Now, something that you need to realize also is time weighted for the gym shuttle. If you just highlight this and you do insert, and you put the histogram, it's going to do something weird like this. And remember what I said about having pretty stuff on the bottom? It's kind of weird and I don't like it. And so I'm going to come in here. I'm clicking on this. I click on this bottom thing and it brings up this option right over here, and I can say bin width, and I want to do a bin width of 5. And there's a reason why. If you look at it, and let's see here, equals 2 raised to the 5th is going to be 32. 2 raised to the 6th is 64. So that's the 2 to the k rule. So it should be 6, which we could also do that as well. And let's see here. Let's do number of bins, 6. And you'll see that it looks a little bit different. It doesn't break up the bins perfectly at 6. What you could do is 3.5, and then it's a little bit cleaner, and then you'll see some that are higher than others. But the truth is that it's pretty evenly split, throughout that time. Even if you do split it out, depending on how you split it out, it's going to show little differences all throughout. And the truth is that it is completely random. And it is uniform. You just need a bigger sample size to really show that it's completely uniform. So, but what I wanted you to see is you look at this and it is uniform. So let's see here, the waiting for machines. Right here, we talked about if there's some individuals that don't have to wait at all, but the majority of individuals wait, a longer period of time, this would be negatively skewed. It's skewed towards the left-hand side, because there's a few people that barely have to wait at all, but most people have to wait this much, so it's negatively skewed because those people who have to wait less are skewing it that way. Then ideal time to work out. There's some people who work out really early, some people who work out late. And this right here, even though, you look at 19 to 21, that is the largest mode. This is what we would refer to when we're talking about the shape of data. This is bimodal data, because you've got one set of data over, or one concentration of data over here, another concentration of data over here. So that would be bimodal data. Now, this right here is something a little bit different. And this is how to do percent by hand percentages. And we have, let's see here, how many data points? We have 51 data points. And when you've got these data points, let's see here, ideal outdoor temperature for eating was what this is right here. So it's like, hey, it was supposed to be ideal outdoor temperature for exercising. I don't know why. Hopefully I must have ideal time for exercising and ideal temperature for exercising. And so yes, this is the ideal outdoor temperature for exercising. And when you look at this right here, we've got the positions. So I put these in order from first to last, or least to greatest. And when you do that, you've got the first person there right here, the second person is right here, third person is right here, and each one has a position. And what we're going to do is we're going to try to split these people up. If you were to split them up by percentage, you would split them into 100 equal groups. If you were to split them up by deciles, deca is 10 even groups. Or if you were to split them up by quartiles, you want to split them up into 4 even groups. And so there are a few ways to go about doing this. And doing it by hand, what we're going to do is we're going to find the locations first, and then we're going to find the value that corresponds with that location. So if there are 51 data points, what we're going to do is we are going to use the formula that's on your formula sheet, or we can also just come over here where you'll see this formula. It says finding the location of Q1 is 1/4 multiplied by n plus 1, n being the number of values in the data set. Okay, so let's go ahead and do that. So let's see here. I'm going to I'm gonna do just right here equals well, let's do 0.25 because 0.25 is 1/4, or you can do equals 1 divided by 4 multiplied by n plus 1, so 51 plus 1. And there is the reason why you do 51 plus 1 is because the quartiles assume, hey, you're splitting up one whole set of data, and so adding that 1 allows you to say we're splitting a certain amount above, a certain amount below. So by adding that 1, it allows you to say 25% is below quartile 1 and 75% is above quartile 1. If you didn't add that 1, then you'd have to be like 24% below, or 24.5% below, and 74.5% above, and it just wouldn't work. And actually, I think it'd be 25% below and 74% above. But yeah, so we've got this right here. 13 is the location, or the position. So we come down to position 13, and it's that value right there. Okay, so with that value, that is the actual value of Q1. This is the location, this is the value. And then if we wanted to find the location of Q2, or the median, you do n plus 1, so 52, multiplied by 1/2, which gives you 26. So it gives you the 26th value. And then the corresponding the 26th location corresponding with the value of 71. And then Q1, sorry, Q3 is going to be 3/4, and that's because there's a total of 4 quartiles. It's 3/4 for the third quartile multiplied by 51 plus 1 equals 39. So you go down to the 39th value, and the corresponding value is the 39th position. The corresponding value is 75. And so that's how you go about doing that. Now we're going to do something else as well, and that is I'm going to highlight this. Actually, I'm going to highlight this, and I'm going to do insert. So I'm highlighting ideal outdoor temperature for exercising, insert, and we're going to do this fun little it's called a box and whisker plot. Okay, because you've got a box in the middle, and then you've got these whiskers. And we have yeah, we have all these values, and when we have these dots, those are referred to as outliers. So according to this, it looks like we've got 3 outliers below, although there could be more than one outlier exactly at that point and more than one outlier exactly at this point. So you notice this right here, the corresponding thing on the corresponding value is 55. You look right here, there are 2 55s. Right here, there's it's 59. That's 59, and then 15 is right down there, and then right over here, it should be 89, I believe. So, yep, 89 is also an outlier. So all the outliers are highlighted right here. And then we're going to change this to ideal temp for exercising. Now the question is what defines what an outlier is? So in order to determine an outlier, we're going to establish what's referred to as outlier limits. Outlier limits is a value that says anything below this value is an outlier or lower outlier, or anything above this value is a positive outlier or the upper outlier. And in order to do that, we're going to use these formulas right over here for the outlier limit, and it's also on your formula sheet. Okay, so right here we have first step. We've got to find the interquartile range. So the interquartile range is the value of Q3 minus the value of Q1. So Q3, which is 75, and then Q1, which is 70. So the interquartile range is 5, because it's 75 minus 70. So let's do 5. Okay, and then the lower outlier is going to be Q1, so the value of Q1, which is 70, minus 1.5 multiplied by the interquartile range. So we do equals 70, or 70, okay, minus, put this in parentheses, 1.5 multiplied by 5, which is the interquartile range. Okay, so that gives us our lower outlier limit, and then the almost the same exact thing equals Q3 plus 1.5 multiplied by the interquartile range, which is 5, and we're just going to put this in parentheses because I know you don't have to because of order of operation, but I just like to make sure to keep it really clean. So basically what we have is anything below this 62.5 is an outlier. Okay, so you notice here, draw an imaginary line, and it says anything below that 62.5 is an outlier. Okay, then anything above this 82.5 is an upper outlier. So we have a total of 5 down here. Okay. Interesting. So you notice right here, this 59 and 60. Let's see if I can zoom in more. There, for some odd reason, it's not showing that dot, that 60 dot. And it's definitely an outlier, and it even shows that it's an outlier, but it's not showing that 60 dot in there. So you just have to be kind of careful. You know, a lot of people would just say, oh, there's 4 outliers. There's not 4 outliers. There's 6 outliers. And so make sure that you actually realize what is an outlier and what's not an outlier. Okay, so what you're going to be doing is for this one, you're going to be doing the exact same thing. It's already ordered from least to greatest. And then you've got to, let's see here, this one's got 68 observations, as do both of these. Yep. So these all have 68 observations. So I'll get you started on this. Let's just put this right here because that makes a lot more sense. It's not covering anything up. Okay, so we've got equals 1 divided by 4 multiplied by 68. Just make sure. 68. Yep. Multiplied by 68 plus 1. Okay, so it is the position 17.5. Well, I'm kind of glad I did this. The reason why, let's do this. 1, 2, 3, 4, 5. And we're going to go to 17.25, which is right in between here. Now, we do not have a 17.25th value. What we have is a 17th value and an 8th value. Now, with the median in a previous lesson, we talked about how you would take the average of these two. In this case, it's 3 and 3, so it would just be 3. But if this was 3 and 4, you would not just take the average of these two. If this was 3 and 4, what you would do is you would find the difference between these two. So in other words, equals 4 minus 1. And then you would multiply it by whatever that decimal point is. Okay, so 4 minus 1 multiplied by 0.25 plus the 17th value plus 3. Okay, so 4 minus 3. Bah humbug. Sorry, 4 minus 3 multiplied by 0.25. So this minus this multiplied by the decimal point or the remainder multiplied by 0.25 plus the 17th value, and that gives you the value of the Q1 right there. But this is actually 3, and so the value is still actually just 3. So Q1 is 3. Let's do this. Q1. Okay, and then we're going to find the median. So once again, how many observations do we have? We've got 68 observations. So the median is going to be equals 68 plus 1 divided by 2, or multiplied by 2 over 4, or 1 over 2. Multiply, not, there we go. So it's 34.5. So we're going to come down to the 34.5. Once again, both of them are just 5. So we've got Q3, or sorry, we've got median is the 34.5th value, and the actual value is just 5. And then last but not least, we're going to do, let's see, equals 3 divided by 4 multiplied by 68 plus 1. And that's 51.75. Oh, wonderful. We finally have one where there is a difference. So 51.75, which is right there. And then we'll do Q3. And Q3, once again, what we're going to do is equals 6 minus 5 multiplied by the remainder, which is 0.75, plus the value, the 51st value, which is 5. And so the Q3 value is 5.75, which splits Q3, so this is technically Q3, and then this would be Q4. So let's back up just a little bit. Well, I'm going to highlight all of these quartiles. Yep. We've got this quartile. And then we've got this quartile. And then we've got the next quartile. And then we've got the last quartile. Okay. And if you were to go through, let's see here, we've got 17 values, 17 values, 17 values, and 17 values. So this is this right here is 4 quartiles. And we can do the same thing, insert box and whisker. And here you don't have any outliers at all. But the other thing that you really need to pay attention to, so I'm gonna do something, I'm gonna zoom out a little bit and do something. And it does not like me. But something that I wanted you guys to see, we've got quartile, this is technically quartile 1, so it's those values up there. So quartile 1, quartile 2, quartile 3, and quartile 4. Even though these are all different sizes, quartile 1 and quartile 2 are about the same size, but quartile 3 is really small and quartile 4 is not very big either. But even though these have different widths, they actually have all the same number of observations. So there's 17 values in here, there are 17 values in here, 17 values in here, and 17 values in here. The other thing that I want to do is I want to click on this and I'm going to do chart design, add chart element, and I'm going to put data labels off to the left or off to the right. I really don't care where they go. And I'm going to make this just as long as they're legible. Okay. Okay. So what we have here is we've got the minimum value, which is 1, the maximum value, which is 7, Q1, the median, and Q3. Those are technically the only things that have to be in this, but I also like having the mean in there, which you see this X right there, and the mean, which is that value, including the mean allows you to tell the skewness of the data. So this right here will tell you the mean is less than the median, therefore it is negatively skewed. Okay. So this very last thing that you've got to do, make a box and whisker, and then, oh, sorry, make sure that you finish this as well, ideal time to exercise, so do that one as well. And then the box and whisker, what you're doing is just making 5 box and whiskers, and yeah, for this one, you can literally just highlight all of them at the same time, insert, box and whisker, and you can put all of that information in based on what it is, and just add the chart elements, data label, literally just read this chart down here and put all the views here, as you're going. One thing I'll be able to is the location. So for the location, you're still going to have to use the formulas each time. So just be aware of that. And those formulas that I'm talking about are these formulas right here. This will give you the position each time. Cool. Let's see here, and that's all that I got for the Excel. The other stuff down here is hopefully what we're doing in the next class period, or I will make sure that it's yeah, I'll get a lecture up. Oh no, these I need to get a lecture up on this. I'll get a lecture up on this, and this one already has a lecture up, and yeah, cool. That's all I got.